In this lesson, we're going to take a look at some algebraic terms and terminology. And there's the first example asked to identify, and this is some terminology, the coefficient and variable in some terms. So these are 5 examples of terms. Now the coefficient is the numerical part, the number usually in front. Front means the left side of the term. So the 9 in the 9x is the coefficient, or numerical coefficient, some people call it. And the variable is the letter. So the variable is the x here. Now, a variable means something that's unknown. The amount can vary in different circumstances. For example, it could assume different values. And so that's why it's called a variable, because it could have any of a number of different values depending upon the situation. So instead of saying 9 unknown quantities, we'll call it 9x. So like the 9x is the mathematical shorthand instead of having to write the word unknown all the time. In negative 4.9 t squared, the negative 4.9 would be the coefficient, and the t squared would be the variable part. Now you might recognize this 1/2 BH as the area formula for a triangle. And so the half is the coefficient and the BH is the variable part. So here's a more concrete example of what unknown means. There's lots of different triangles that we could find the area of. And if we selected 20 different triangles, they might all have different bases and different heights. So that's what I mean by those numbers can vary. B represents the base length and H represents the height of the triangle. In m cubed, now if you don't see a number in front, there's automatically a 1. So m cubed is the same as 1m cubed. So the coefficient's 1, the m cubed, or m to the power 3, would be the variable part. If you just see a number like 15, the 15's the coefficient, and there is no letter, so there is no variable part at all. Now, algebraic expressions are also called polynomials, and we'll probably look at a more strict definition of what a polynomial is in a later lesson in this course, but we'll just call a polynomial is a group of terms added or subtracted together. So if we have a polynomial with one term, it's called a monomial, and here's an example, 8x cubed. There's one term there. A binomial has 2 terms, just like a bicycle has 2 wheels. And so here's an example of a binomial, 10a to the 5th plus 2a. A trinomial, just like a tricycle, has 3 wheels, has 3 terms. A trinomial has 3 terms. So x squared minus 4x plus 9 is an example of a trinomial. In the second example, you're asked to identify the polynomial type. And so we're talking about classification degree here. So the classification is just what we were talking about a moment ago, whether it has 1 term as a monomial, 2 terms as a binomial, etc. And so this has 1 term, the negative 3x, so we would call it a monomial. Now the degree of a term, or a group of terms, a polynomial, if you look at a term, now there's an exponent of 1 here automatically if you see just x, or whatever the variable might be. So this would have a degree of 1. It would be the first degree. This is a trinomial. There's 3 terms here. Now, if you look at the terms, the one with the highest power is the one that decides what degree that trinomial is. And the x is squared, so the 2 would be the degree. So that's a second degree, 2 being second, polynomial. For C here, there's only 2 terms. 15m cubed n is 1 term, and the 6m is the second, so it would be called a binomial. And now the 6m would just be a first degree term. But the 15m cubed n, now there's a 1 here automatically, just like this had a 1 automatically on the x. So in this particular term, you add all the exponents. So it's not a third degree. 3 plus the 1 here would make it a 4th degree. So that would be a 4th degree polynomial. So it's always the degree of the highest term in it. In the third example, Cheryl works as a part-time ski instructor. She earns $125 for the season, and she gets $20 for every child lesson and $30 for an adult lesson. So we're asked in A to write an expression that describes her earnings for the season. So we could use, now there's two different variables here, the number of child lessons, so we could call that C, and the number of adult lessons, so we could call that A. And it's a good idea to write that down somewhere. So a lot of people call that the let statement, and it simply says let C represent the number of child lessons and A represent the number of adult lessons or something like that. Now the $125 is a fixed amount. So the expression could be something like this, and it doesn't really matter the order. So the 125 is a fixed amount, so we could write as 125 plus 20C. Now 20C means 20 times the number of child lessons, and that's what she gets. She gets $20 for every single one. Plus 30A, and the A represents the number of adult lessons, so we would add that in as well, plus 30 times the number of adult lessons. And so here's my statement which describes what the C and A represent. C is the number of child, and A is the number of adult lessons. So in B here, if she gave 12 child and 20 adult lessons, what would her earnings for the C's and B? So we're really given values to substitute in place of C and A here. So there's the formula from A, and so we're going to put 12 in here and 20 in here. And so this would mean 20 times 12 and 30 times 20. And so if we do the math, 20 times 12 is 240, and 30 times 20 is 600. And if we add the three of those together, we get $965. So that's what she would get for the entire season from all the lessons plus her fixed salary. Last page here, and we've got a couple different examples here. We're going to talk about like terms in example 4, and then do some adding and subtracting in the last part. And so like terms are terms that have the same variable and also the same exponent or power on it. And so if you look in A here, 3x, negative 7, 8x, negative x, okay, there's 4 terms. And the ones that have x or x to the first power are the like terms. The negative 7 is a different kind of term. It's just a constant or a number. So the like terms would be the 3x, the 8x, and the negative 1x. Remember again, if you don't see a number, it's automatically 1. So we could call that a negative x or negative 1x. In the second one, notice there's a 5a squared here and a negative 1a squared in the middle as well. The other terms, the other 4 terms, are all different kinds of terms. This doesn't have a power of 2, that's just a number. This has a cube, or power of 3 instead of 2. And this does have the power of 2, but there's also a b here. So we would call that an a squared b term, not just an a squared term like the fourth and first one. So the like terms would be the 5a squared and the negative 1a squared. In C, the 7y and 2y are like terms, because they're both y terms, but the 4 and negative 5 are not y terms. But the pair of those would also be like terms, because they're just numbers, they're constants. So the 4 and negative 5 are also a different kind of like terms. So actually 2 pairs of like terms in C. Now for the last one here, to simplify a polynomial expression, you add or subtract the like terms. So you group, and the grouping is a good idea when there's a lot of terms until you get used to this. Add or subtract the like terms only. You apply integer rules to the coefficients of the like terms, and we'll talk about that as we go through the examples. And you don't change the variable parts, and I'll discuss that a bit too. So in the first one, it says 2x plus 3x. And so if you have 2 of something and 3 of something, then altogether you have 5 of the same thing. And so you don't change the variable parts. Okay, the last thing there. 2x plus 3x is 5x. Think of it like if you had, let's say you had 2 cats plus 3 more cats, you would have 5 cats. You wouldn't have like 5 cats squared. A lot of people think they have to add the powers to make it like an x squared term. That only happens when you're multiplying, and we'll talk about that in a different lesson. So 2x and 3x add to 5x. For B here, the 4x and 2x are like terms, so we would add 4x and 2x together, and so that would add to 6x, and the 1 and 6 add to 7, so this would simplify to 6x plus 7. Doesn't simplify anymore. That's an x term, that's not, so that's as simple as you can write that. For C here, 7x minus 3x, those are like terms. So if you have 7 of something minus 3 of the same thing, you should have 4 of them altogether. So that would subtract 4x. For D, The 5k and the minus 3k, they're like terms. So 5k minus 3k would be 2k, just like 5 minus 3 is 2. And then these are like terms as well. So the negative 6 plus 3, now that negative belongs to 6. So it's actually negative 6 plus 3 would add to negative 3. So we would write 2k and then minus 3 in the end. Now, here's some grouping. The c squared and the 2c squared, and the minus 4c squared, they're like terms. So let's group those together. And then this term and this term are like terms. So let's group those together, and then we've got this minus 3 in the end. The grouping is a good idea so you can see what you're actually combining together. So 2 minus 4 is negative 2. So that would simplify to negative 2c squared. And then 3c minus 5c would be negative 2c, and then a minus 3 in the end. So that's as simple as you could write that. For f here, 8x and the minus 5x, they're like terms. So 8x minus 5x would be a 3x. And the 2 and the minus 7 are also like terms. 2 take away 7 is negative 5. So that would simplify to 3x minus 5. And for g, I'm going to group like terms again. The 2r squared and the minus 5r squared are like terms. The negative 4r and 9r are as well. And then we have this constant on the end. So 2 minus 5 is negative 3. So we'll start with a negative 3r squared. Negative 4r and 9r add to 5r, just like negative 4 and 9 integer rules. Add to 5, so that'd be 5r, and plus the 3 in the end. And that's the end of the lesson.